Hello, everyone. Thank you so much for being here today. We are very excited to see all of you here. We are also very eager to share with you our perspectives about how to better manage your VM instance. My name is Sophia Yang, product manager from the Compute Engine team. Join me today are two of my coworkers, Karen and Vipti, who will help with some very awesome demos. So let's get started. When talking about running workload on Compute Engine, VM instances are really at the heart and center of everything. We want to make sure you have the right instance to run your job, but also you don't want to pay more. And that's exactly the first section we're going to be talking about, how to tune your VM instance so that you have the best price performance. Next, we're talking about scaling. Most workloads are now done with a single VM instance. How can you scale up and down quickly? That is the second section we'll be covering, both the tools and the demo to show you the performance we can achieve. Third, backing up. No critical workloads can be done without a good backup and recovery story. And in that section, we have brand new features to share with you to help you better back up your VM instance. And last but not least, secure. How can you make sure you can manage the access control to your VM instance so that your data, the environment is all protected? And at Google, security and privacy is always our first priority. And there, we're going to share you some tips and new features about how to better control the security and to secure a VM instance. First, let's talk about tuning, picking the right VM instance. So if you were going to ask me, what is the right VM instance? For me, then, I can't tell you that because I have to ask you back, what is your workload looks like? The right answer is the VM instance size always depends on your workload. So let's first look at the popular workload running today in cloud. Here's just a list of them, and the list goes on and on. Basically, at Google, we understand customers come with a diverse set of workload. They all have a diverse set of requirements. And we are providing a wide range of selection machine types and VM instance and features to make sure we can meet all your workload requirements. Here's just an overview of what the general categories of the machine types we're offering at Google. We have general purpose, memory optimized, and the shared cores. Within each family, we also allow great flexibility so that you don't have to think too much on the constraints in terms of what you should do in order to utilize certain features. What do I mean by that? For example, let's dive into the general purpose machine types, which is our most popular machine type. Within the general purpose pool, we have 3 families: standard, high memory, and high CPU. They are really designed to be suitable for majority of your workloads. So if you have the web server you're trying to host, the CI/CD workload you're trying to run, chances are you can find the best suited machine within this general purpose machine type. They're highly available across all regions and zones. And just remember I mentioned that they are very flexible to use. For example, you can attach local SSDs and the GPUs to all of them. Unlike at other cloud providers, you have to think about, what size or what generations I have to use in order to, for example, use GPUs. At Google general purpose machine types, you can attach GPUs and local SSDs to all of them. Better than that, we also allowed a wide range of core to GPU ratios. For example, at Google, if you only need a 1-core VM to do your job, but you would like to have 4 GPUs to have a better parallel computing, you can do that combination, but not like other cloud providers. You have to have a much bigger VM in order to have 4 GPUs. Within the predefined families, all the machines comes with 1, 2, 4, all the way up to 96 cores. So the next very natural question will be, say I pick the 8-core machine. How can I make sure I'm maximizing all the compute power? How can I make sure I'm utilizing all the money I'm spending? And that is an excellent question. In fact, RightScale recently did a study and showing they estimate about 35% of cloud spending are all wasted. Why wasted? Just as an example I mentioned, you have an 8-core machine, right? But your workload actually probably only needs 6 cores. So there's 2 cores that are wasted. Another more extreme example, What if your workload need, say, 18 cores, but so 16-core machine wouldn't be enough, while the next in line, if you need to jump to, will be 32 cores. So that will be almost double the compute power you need. So which options are there? You can, one, pay that double the money and so that you have the maximum performance. Or you retro code, re-architect so that your workload run could fit in better in the 16 cores. None of them ideal options, right? And in fact, all the cloud providers know that not all the predefined machine size can fit all the workloads best. But why they haven't done anything yet? The truth is, the cores you are now using, that's a great news for the cloud provider because they can then sell that to other people, right? But at Google, it's different. We want you to get exactly what you need without paying any more. And that is why we offer custom machine types. As the name suggests, you can customize the number of cores and memories exactly as you want with all the flexibility you want. Within custom machine types, you can even achieve higher memory to CPU ratio compared to general purpose machines. This is a great use case if you have a certain, say, licensing requirement. If your OS or application providers, say, charging you based on the number of cores you have, so you want to kind of be conservative there. But you also want a large amount of memory to maximize your workload performance, and you can do that with extended memory within the custom machine type family. To get started with custom machine types is very easy. Just define the number of cores and memories you need, as the example shows on the screen. You can, in this example, you create a new VM with a custom machine type. You can also update existing machines to a newer VM shape just by stopping the VM first. As mentioned, general purpose machine types is the most popular machine types at Google, plus the custom machine type. They should be able to achieve the performance you want with most of your workload requirements. And in fact, more than 99% of our customers today are running on these custom machine types plus the general purpose machine types. And next, let's see some other options and the features you might be able to utilize to maximize your workload performance. The next one I want to touch about is the preemptible VMs. What they are really just short-lived, low-cost VMs. How short-lived? They can only run up to 24 hours. And that is not, if not Google preempt you before that. Google might preempt your VMs at any time with a 30 seconds notification. So your workload better be pretty robust so that you can handle that kind of preemption. And what is the plus side? The price. You can save to up to 80% compared to the listing price for regular VMs. Another very powerful thing to realize, you can make any machine types available at Google as a preemptible VMs. You can just change a setting, a property within the VM instance, make it a preemptible. And there you have it. They're really suited for, say you have fault-tolerant workload as a batch job or media rendering, genomic kind of jobs, or short-lived jobs. They are not very suitable if you have a job that you have a certain deadline. Say, in the next hour, you want to run a business report. We don't recommend you to run on preemptible VMs. Next, memory-optimized VMs. We know a lot of enterprises, probably many of you sit here, you're in the process of migrating your workload from your data center to cloud. We realize one of the biggest challenges to move those large in-memory databases like SAP HANA. A lot of times, because they couldn't find a suitable hardware on cloud that can run your big memory machines, customers are forced to set up this hybrid environment because they already moved their applications, web servers onto the cloud, yet they have to leave their memory-optimized VM behind because they just couldn't find the right thing in cloud. Well, if you are one of those customers, you'll be happy to find out that Google offers the memory-optimized VMs, which can provide you up to 3.8 terabyte memories. That is a lot of memories. Within the memory-optimized VMs, we have 4 machine types, as you can see, and you can achieve as high as 24 gigabytes per CPU ratio. And you might be thinking, oh, these must be very expensive. Well, they're probably more expensive than the share cores or one-core VM. But if you look at the price per gig ratio, they are actually the cheapest among all of the machine types. So they're also very cost effective. So if you are one of those customers, you have a big in-memory database like SAP HANA you want to run, now you never have to leave them behind while move all the workload on cloud. So go ahead and try those memory optimized VMs. And if you missed the news from last week, we're happy to remind you that we just made these memory optimized VMs to be generally available for you. Well, after talking about memory-intensive workload, let's talk about compute-intensive workload. Last February, also in Next, Google announced the generally availability of Skylake CPUs, which made us the first ever cloud provider supports the latest Intel processor. Skylake, the benchmark shows if you enable the advanced instruction AVX 512, you can achieve it can double the floating point calculation compared to the previous generation. So it's super powerful if you have a high compute-intensive workload. They're perfect for scientific modeling, 3D rendering, and in order to utilize in order to select the Skylake CPU, you can utilize our min CPU platform selector function within the VM instance. As the example shows, you can just define, say, min CPU platform equals to Skylake, Intel Skylake. Then Google will make sure your VM will land on the hardware that has Skylake, or even later generations when they're available. All right, since we're talking about the use cases of customers, we have seen another common use cases is that, especially from certain verticals or industries like finance, healthcare, the customers have regulations they need to meet in terms of where they can place the VM instance. And if you are one of those customers, you'll be happy to find out Google offers sole tenant nodes, which are physical servers dedicated solely for you to use. So different from regular VMs where you have to share the physical host with other customers, you can achieve performance isolation so that you can have, as you have this whole server dedicated just for you. To get started, it's very simple. Just create a sole tenant group using the template, and then you can schedule VM instances onto those sole tenant groups. In terms of where the VM will be placed, we have a great flexibility offered there too. So you can obviously directly explicitly tell us where the group you want to target, or you can use labels and label selectors. So in order to utilize that, you will first define labels for those groups, and then you can have multiple labels for each group. And then when you're scheduling the VMs, you're targeting those labels. You can say, place this VM on a group that is the environment equals to test and the team equals A. And then Google will find the best place for you that meets both requirements. Or you can use anti-affinity. You can say, place this VM in a group of A, but environment does not equal to production. So you will achieve both anti-affinity and affinity with our labels design, which is very unique and a flexible offering. Last point I want to mention about sole tenant is you can also mix different shapes of VMs onto the same host. Again, at Google, we always think about your need. We want to give you the max flexibility, also allowing you to best utilize all the resources you got without any artificial constraints. What is making it better? Today, we'll let you know that the sole tenant nodes are going to be generally available for you in August. That's really just next month. All right, we have talked quite a bit about different VM types, machine types, and features you can utilize in order to best achieve your price performance. So I want to make sure you guys are still with me. So here's a quick overview of the things we already talked about. And actually, I would like to ask the audience some questions, since we're all so close. Just making sure you were paying attention, right? So given the same machine type, which one saves you the most money? Great, yeah, preemptive VMs, great. Let's say, what if you have an SAP HANA? What machine type probably the best for you? Memory optimizer, great. Let's try the last one. What if, say, you don't want your VM, you want to schedule VM to somewhere that you don't have neighbors you don't know? Great, which is going to be generally available for you next month. All right, next, let's move on to the second point, scaling. Most people here don't just want to run single VM, right? How can we quickly scale it up and down so that it gets your workload in? We're going to cover that in this section. We're going to first tell you 2 tools that you can utilize, and then have a great demo for you. So first, let's talk about the 2 tools you can use. Earlier this year, we made this feature available for you that is about creating individual instances from a template. This allowing you 2 great use cases. One is you don't have to create a VM instance from scratch anymore. So what you can do is that you can create a template, define all the images you want to use, disks, etc., and then quickly duplicate the VMs from there. Another use case, we have actually learned this from IT admins, that they often want to issue some recommended shapes of the VMs to their developers, using the approved image they want, using the kind of subnets or firewall rules they want. So how to kind of pass down this requirement easily? They can create those instant template so that developers know exactly where they should start. Another thing to mention, if needed, you can override the properties within the instant template when you're creating this VM. So again, great flexibility. For example, in this example in the screen, you are providing a source instance template, yet you're overriding the metadata value to be a new value so that it to achieve exactly what you want. Next, if you prefer Google to manage the VMs, the group of VMs for you, to scaling up and down for you, then you can utilize our managed instance group offering. There are 2 modes you can use. One is fixed size. Say you define 100 VMs in a group, and Google will make sure we maintain the 100 for you, and do the health check. If we realize any VMs unhealthy, you can take them down and bring up a new one for you. Another mode is auto-scaling mode. You can most likely connect that to a load balancer, and we can scale up and down based on your workload, based on your traffic. And the regional failover, because we support both zonal managed instance group and the regional. So if you're utilizing the regional managed instance group, it can avoid some zonal outage. And if you want to learn more about this managed instance group, there's a session tomorrow for you that you can attend. This is going to be delivered by my coworker, Mikola. All right, so as we talk about the features used to help you scale up and down, I think another common concern from customers will be, oh, wow, I have to scale up and down this many VMs very quickly. So what kind of performance Google can deliver? And if you're one of if the customer had that kind of question, you'll be happy to find out Google has excellent performance, especially in terms of bringing up VMs, a group of them. As Gartner said it, Google has exceptional fast VM provisioning time. Also, here's another quote from our customer saying, they think, and we think too, Google is the best cloud platform because the great stability and the performance. All right, so we have analyst reports, customer quotes to prove my point. But what is making it even more convincing? Wouldn't you want to see how quickly we can bring up VMs in real life? So today I would like to invite my coworker, Karen, here to give you a live demo to show you how quickly we can bring up VMs up and down.
Thank you, Sophia. Thank you.
Oh. All right, let's switch to the demo source.
Okay. So for the demo, we have prepared instance template that specifies a general a machine type with 1 core, and we created a managed instance group in European zone, and we're going to scale this managed instance group up to, say, 50?
50?
50 VMs, or...
Do you want to see more?
Let's try 100.
Okay. Do you want to go to the website?
So this is the console for managing the instance groups, and we're going to update the existing instance template and change the number of instances to be 100. And the VMs that are going to start up, they have an image and have a startup script that as soon as they come up and boot, they will ping the web service that we deployed, and the web service will visualize the
master node of the web
the
network.
VMs that are coming up. So this is the web service that detected that instance group is scaling up, and it times up calculates the time it takes to receive messages from the slave nodes as it receives them. So during this period, the VMs are allocating compute resources, IP addresses, and they are being booted, programmed to the network, and then they start pinging the web service. And as you can see, within like 40 seconds, we got all the VMs started, booted, and running the customer workload, which in this case is pinging the master node.
Wow, 41 seconds, 100 nodes. I feel the longest wait is actually the VM provisioning time, where, as you mentioned, allocating the IPs, etc.
True. I think the demo was faster than we usually see. But this is
Don't tell them that.
So maybe we can try something bigger and spin up more VMs, like go higher number.
How high you guys want to see them? 1,000? Did I hear 1,000? 10,000? Should we put 10,000 load onto our production system?
We can do that, but it will probably take a little bit longer and bore you guys. So let's try the 1,000. Maybe.
Sure. But before we start, let's have a guess. Well, 100 is 41 seconds, so how long should it be 1,000 be? People are good at math, right? But let's see if we can do better than linear scaling.
Yeah.
By the way, that's the right answer, I think. 41 times 10.
OK. So the instance group is now scaling up to 1,000 VMs, and we already see the VMs showing up in the managed instance group and see what the web service is.
So the counter restarted, and we're trying to see if we can.
Yeah, the timer restarted, but we already have the 100 VMs from the previous action. So we're going to wait for another 900 VMs.
Mm-hmm. Well, I already see VM starts coming in as we speak.
Can I ask a question while you're waiting?
Sure.
What is the health check that you're actually confirming when an instance is up? Since I noticed in your configuration that you didn't have a health check enabled.
The VMs that are already running the customer workload, they ping the master node, so that's the custom startup script that the VMs use, and that's how we detect that the VM is already up and running the user code.
Well, the number quick is going up. We can see already 400. It's real demo, or live demo.
This is real demo. Yeah, because this depends how busy the cluster is. So there is also other customer workloads running in European zone that we are accessing. So
Yeah, we have customers in Europe, a lot of them. Yeah. That shows our compute power, right? People don't stop computing. And great, I think this is done.
So it
wow.
took like less than 2 minutes to provision thousands of VMs.
A lot faster than the 400 seconds, right?
Yeah.
That is so awesome to see.
So as it's important to provision the VMs fast, it's also important for the workloads to deprovision the VMs. And that's usually in the scenarios where you want to update your cluster, tear down the existing VMs, and start new ones. So we would like to also demonstrate the deprovisioning and deleting the VMs. So I'll go ahead and remove all the VMs from my instance group, resize it to 0. And in this case, I'm not going to look just the shutdown script of the VMs, because the first thing that we do in GC, we stop the guest OS from running user code, but then it takes some more time until we release all the compute resources, IP addresses, and delete the resources from our database. So what the web service does, it monitors all the VMs in managed instance group and makes sure they are fully deleted before it's showing as teared down in this visualization. So Like if we go in this page, you will see some of the VMs are being deleted, and they probably already stopped running the workload, but we still have them here. We already got several of the VMs deleted, but it will take a little bit more time to tear down all of them.
But we can see VMs are already start getting down. And I think in addition to what you mentioned, the use case like CI/CDs or updates that you want to kind of quickly tear down your cluster so that you can start the next one. Also, I want to remind you, you don't stop paying until the VMs are stopped or deleted. So being able to do so quickly for a large amount of VMs also saves you a lot of money. So the question is, when we're deleting them, do we have like a kind of undo option to cache them for a little bit?
No, when you delete, they are permanently deleted. Like if you delete the VM, their disks are not necessarily deleted. It's an option that you can specify, and we can delete just the VM, but the disks will stay longer. Yes. And I think.
Well, we're almost done there. Yeah.
Yeah.
Already only 65 left, and it seems like a little over 2 minutes.
Yeah, I think deletion took a little longer than the 2 minutes we've got for creation.
All right, it's almost done. I think the next I refresh. Great. Oh, so 7.
I think it's okay to skip those. So. Yeah. So I think if you try to tear down existing cluster and then provision that from scratch, it will take you less than 5 minutes to do that with 1,000 VMs. So.
Great. Thank you so much.
Thank you, everyone.
Isn't that amazing? Thank you so much, Karen. And I think I forgot to mention Karen is one of our technical lead to make all this possible, to make the spinning up and down possible quickly. Thank you. All right, so can we switch back to the presentation? All right. So next, let's talk about backing up. As mentioned, no matter you have this database or shared file system, whatever the important workload, you want to have a great backup story to periodically back up your data to make sure you have a great checkpoint to go back, right? So in this section, we're going to tell you 2 tools you can use to better back up your VM instance. The first one is use instant template, which is similar as we touched earlier. We mentioned about using instant template to create multiple VMs, and in this case, you can also use the other way, which is creating instant template from the existing VM. Why this is useful? Because we have heard of many the use cases, especially as a developer trying to prototype something, starting off from a new project. They often start with a VM and then tweak it to exactly what they wanted. Maybe add the disk, maybe change the network, etc. So once they're done to tweak it, get to exactly the golden state, they might not actually need a VM, because of prototyping. But they want to make sure they save the configuration so that they can go back to recreate that. And if you have that kind of requirement, you can generate a instant template from the VM. To use the instant template is almost like the configuration of the time machine of the configuration of your VM, so that you can go back at any time without paying any extra money, because as the VM is already deleted. To get started, it's also simple. Just as the example shows on G-Cloud, you can just simply provide a source instance while you're creating the instant template. So this is another great tool to know how to save your configuration of your VM instance. And next, obviously, when we're talking about backing up, the most important thing is to back up your data on the disk. You probably know about a snapshot. We already provide a feature, and that's a great feature, very high performance and a space efficient offering that Google already offer. But you might want to ask, how can I periodically generating snapshots? Well, without any help from Google, you can use a cron job, but customers have been telling us it's a pain to manage, right? Especially including deletion, we have to manage that. And if you are one of those customers, you'll be really happy to find out. Google now will offer you the scheduled snapshot feature. What this does is exactly meant to replace your cron job. What the scheduled snapshot support is, we will support The frequency of creation snapshots will be hour, day, and week based. And we'll also support retention policy as the number of days you want to keep the snapshot. So you can simply create a schedule, looks like create me a daily snapshot and delete after 14 days. Very flexible to use. You can create that schedule and then attach it to multiple disks so that you don't have to do that again and again on every disk. One thing to call out, this is the same, the snapshots created the same as regular snapshots. They are incremental snapshots. Sometimes people call it differential snapshots. What this does is it only takes the snapshots of the delta of the change between the n time n and n plus 1. So if you have a very minimal change or if no change between the two times, your snapshot size is going to be very small, so you're not paying the whole disk size. So very space efficient, high performance, and also price efficient. And you'll be very excited to find out this feature going to be available for you for beta very soon. So next, I would like to invite my coworker, Vibhuti here, also the lead engineer who made this feature possible, to give you a quick step-by-step guide on how to create schedule snapshot. Vibhuti?
Hi, thanks, Sophia. As Sophia mentioned, now taking periodic backup of your disk has been made really easy. All you need to do are 2 steps using our G-Cloud. First is to create a schedule in which you specify a start time that tells us the time of the day at which you want the snapshots of the disks to be taken, and then you specify the frequency for those snapshots. And as Sophia mentioned, it could be hourly, like every hour, every 12 hours. It could be daily, or it could be just certain days of the week. And once you create the schedule, we also need to specify some retention with max retention days so that we know how long to keep your snapshots for. And after those many days, we automatically clean them up for you. Once the schedule is created, you can add it to one or multiple disks within the region, and it can be either done on an existing disk, or it can be done while you are creating your disk itself. So since these snapshots are created as per the schedule, so I can't demo this thing instantly like Karen did, but for the demo purposes, I have created two such schedules. And next slide.
Okay.
So one is hourly with 2 days of retention, and another one is daily with 3 days of retention, as you see. And here I specify the start time to be 12 p.m. And let's see how these generated snapshots are looking. And I created this schedule just a few days back, like 4 days back. Can we switch to the demo, please?
I think it's the second tab. Yep.
So here, and let me just filter by the disk with a daily schedule. And here we see exactly 3 snapshots, as my retention was 3 and my frequency was daily. If I go into the details of the snapshots, I see the name itself has the name of the disk, the name of the zone where the disk resides, and also the timestamp so that it's easy for you to read and know that when the snapshot was created. And as we see, the time matches exactly 12 p.m., somewhere around 12 p.m., as it takes few seconds to actually finish uploading the snapshots. And as we go back, as Sophia mentioned, our snapshots are incremental. I didn't change anything in those disks for last 3 days. So only the oldest snapshot is a non-empty snapshot, and others are empty. And you will not be charged for the empty snapshots. So basically, you'll not be charged just for creating the periodic snapshots. Instead, you'll be charged for only the change that you make to your disk. And let's now filter by the disk with an hourly schedule. And here you see a lot more snapshots because these are being created every hour, as you see by the name. And none of these snapshots are old. The oldest snapshot is also 2 days old because I had specified the retention to be 2 days. I hope this feature helps you to manage your backups much better. And thanks, Sophia.
Thank you, Vivti. Great feature. All right, let's switch back to the presentation. Great. So last point I want to talk about security. How do you secure the access to your VM instance? How can you protect the environment? So there are 3 things we would like to introduce you in that section. The first thing is the famous identity and access management, or so-called IAM. For the few people that don't know what IAM is, I will just give you a quick crash course. IAM is about defining who can do which actions on what resource. So that's abstract, right? Let's just have an example. So you could assign me, Sophia, the instance admin role onto your test project. That's going to allow me to manipulate and manage your instances in your test project. But you did not give me the same permission to your production project, so I wouldn't be able to do so on the production project, right? So that's kind of fine control on the access control. So with the newly released resource level IAM feature, now you are able to assign IAM policies on individual resources like VMs, disks. What this allowing you to say, common use case will be, I have one instance I would like to collaborate with you, troubleshoot with you, but I don't want to share everything else in the project with you. So I don't want to set a policy on the project. Instead, I want to set an IAM policy on the instance. And then you can achieve this by simply, as the example command shows on the screen, you can set IAM policy on the particular instance, and I will have the full access to it. With that, I would like to also give you guys a quick demo on how this resource level IAM work. And by the way, this feature is also going to be available for beta very soon. Can we switch to the demo really quick? So for this demo purpose, I'm using a demo account I created, and this is myself, who is the owner and have all the power to do everything in the project. And I create another test account, which is David, who also is looking at my project. But you can see the difference. As a project owner, I can manipulate all the instances if I want to start or stop them. Yet David, as just a viewer of the project, he's not allowed to, as you can see, he is not allowed to stop a VM instance or start. See, he doesn't have the permission. He cannot also SSH into it. Again, no permission, right? Say there's a situation arises. I do need now David to be able to SSH into my machine to help me troubleshoot or something. I can go ahead and set a policy on the particular VM. Let's just copy his username. Well, great. 1, 2, 3, 4, 5, 6. Let's copy his name. And I will go ahead to my console. My view, which I'm the instance admin, I'm the owner of the project. I can go ahead, set the permission, which is opening the set panel, and adding the member of him, and giving him the permission of, say, instance admin role. And add. Simply by doing so, I'm giving him the permission to the particular instance that was 11. So let's go back to his view. Let's refresh his console. And now you can see this particular instance 11, he can SSH in, and he has the permission to stop or suspend the VM instance. So that's the resource level IAM policy going to be available for you beta very soon. Let's move back to the presentation. And next I want to mention is about how to protect your operating system, right? How to prevent people that are not authorized to be able to SSH into your machine. And that is, OS login is a feature you have to learn there. So before the OS login feature available, the world was like the only way to log in your VM is through setting the SSH key on your VM instance metadata or the metadata on the project level. The problem with that is, as soon as the SSH key is set, there's no connection whatsoever with the SSH key versus the user. So that's making managing the access or revoking keys very, very difficult. So this employee could have already left your company, but as long as he still knows the key value pair on the SSH key, he can potentially still log into a production environment, and that exposes a lot of risk to you. With OS login, we made a strong connection between the SSH key and the user identity, which IAM control, so that the user no longer logging in by just the metadata set on the SSH keys. Instead, the user will log in with their own identity. With OS login, we have 2 roles available, IAM roles available for to assign to users. OS login, which is the normal non-root access kind of the user, and the OS admin login obviously offers root access. But no matter which role the user is assigned to, they will never log in as root. They always log in as themselves. So that is also making auditing very easy later on. And we also offer the admin SDK directory API, which allowing the admins to manage and set those SSH keys on behalf of users. So OS login, great feature to manage your operating system access. And the very last feature we'd like to share with you to help with better access control is organizational policy, org policy. Org policy is really designed to work hand by hand, side by side with IAM. But the key difference between IAM is org policy has the enforcement regardless this IAM access. For example, we have the first one, no external IP org policy. Say if you set the org policy onto the org level and set deny to all the VM instances that cannot create external IP. So then even your security admin, the compute admin, who should have the IAM permission to create external IP, will not be able to do so. Again, because the enforcement is there regardless of IAM permission. So that enables you to prevent human error. Also enable you to prevent certain internal malicious user. Of course, we hope you don't have any of those. And there are a couple more org policies you can utilize. You can set a VM instance, trusted image, make sure you limit what images developers can use. You want to make sure they only use the supported versions. Disable serial port access, again, to protect your OS system so that no insensitive information can get out from the serial console. All right, with that, let's have a quick review of what we have talked so far. Tuning your instance, scaling, backup, and secure. And if there's one message we want to choose to take away from this talk, and that is Google offers a wide range of machine types and features to meet all your workload requirement need, well, without any artificial constraints and without you paying any more. And if you want to learn more about Compute Engine, there are upcoming sessions you can attend to. That's tomorrow and Thursday, especially if you want to learn more about the security and the privacy and IAM. I have another session Thursday at 1:15.